On 7-11, we're just doing more multiplying, and they're just throwing decimals kind of all over. I'm starting with number 8, and I'm doing this one as a lattice method. Remember, our lattice method, we just look at each square individually. So I have 10, 20, 2 times 1 is 2, 2 times 9 is 18, 9 times 4 is 36, and 1 times 4 is 4. The order that you do them in does not make any difference. Now, remember, we're going straight down the lattice, down the lines, diagonally straight, I should say. So if we go this way, we have 0. 0 plus 2 plus 4 is 6. 1 plus 2 plus 6 is 9. And 8 plus 3 is 11. 1 plus 1 is 2. Now what we need to remember to do when we do the lattice method is we need to remember to go back and say, okay, there's actually a decimal point in front of the 2 and there's a decimal point in front of the 9. No, there is not one in front of the 9. Sorry. There's a decimal point in front of the 2. So I went over 1, 2 places. So in my answer, I need to go over 1, 2 places, and I have a decimal point here. So I have 219.60, and it's really, really important that you remember to put that decimal point in. Moving backward to number 7, I've done out the problem the traditional way here, and if we look again, it did not go, there were no decimal points there, and this decimal point went over 1, 2 spots. So in my answer, I need to go over 2 spots, 1, 2, and there's my answer. Going down to 12 through 19, because the word problems are pretty self-explanatory, I think you can figure those out. But we did this yesterday. Remember, when we're rounding, we want to make sure we're underlining that place value first. So in my example, I underlined here tenths, tenths, tenths. Then what I like to do is I like to draw an arrow over. Some people like to think, oh, that's like 37 and 37. Is it closer to 30 or is it closer to 40? I like to draw the arrow and say, okay, that arrow is pointing to a 7. So the underlined digit goes up. So that's going to go up to a 4. If I look to the right of the 5, it goes to a 9. So the arrow is pointing to a 9. So the underlined digit goes up to a 6. I look to the right of the 9 and it's a 1, so the underlined digit stays a 9. If I look to the right of the 7, it is a 5, so the underlined digit goes up to an 8. Here we're looking at going to the nearest hundredth, so I have tenths, hundredths, tenths, hundredths, tenths, hundredths, tenths, hundredths. I look to the right and it's a 7. If it's a 7, the underlined digit goes up. So that 6 is going to change to a 7. The 0 and the 3 are going to stay as they are. If I look to the right of the 9, it's a 5. It says a 5 goes up. So that 9 needs to go up. But because that 9 is going up to a 10, then this 1, these are the times that it changes because you're kind of thinking that that goes up to a 10, and when you add that together, that's going to get to 0.2. Those are the trickiest ones. If I go to the right, that's a 2, so the underlined digit stays, so I have 0.74. And if I go to the right of the 5, it's a 5, so the underlined digit goes up. Remember, the first numbers, the ones that haven't been underlined yet, those stay the same, and then this goes up. On the remembering side, check your work on the first 3 with my work and see if your answers are correct. Looking at symmetry, that's when we fold something in half, that both pieces will match up with one another. And with a 5-sided star, it has all lines of symmetry. So as long as you're going from a point to a base, all of those pieces will be symmetrical, and it's easier to see if you keep turning the star because sometimes that first one down the middle is the easiest. This one here isn't a rectangle, so we can't just cut it into pieces. We have to cut it this way, and that's a horrible drawing. It should have been from edge to edge or corner to corner. and this way. When it will fold, those will match up. Our piece at the bottom can go this way where it will match up, but it can also go this way. And an equilateral triangle will have 3 sides or 3 lines of symmetry because it's an equilateral triangle.